Okay, so we're rearranging some formulas now. We're going to start off with the k equals 5m plus 7p. Now, this is just like solving an equation. So as far as we are concerned, p is x and everything else is a number. So what I'm going to do is take my 5m and move it away from p. So that's going to be k minus 5m equals 7p. Just like if I was solving an equation, I now need to get rid of the 7, and that means I have to divide by 7 over here, and all this has to get divided by 7 over here. Those 7s are going to cancel out on this side, but not on the other side. P equals k minus 5m over 7. Let's have a look at the next one. We have to make p the subject of this formula. M equals 3n plus 2p. I imagine that everything else is a number apart from p. So the 3n is just some number. I'm going to grab it and move it to the other side with this other number. When it goes over the equals sign, it becomes a minus. So I've got m minus 3n equals 2p. Just like solving an equation, I would now want to get rid of that 2 by dividing. So I've got to do it on this side as well. P equals m minus 3n over 2. And for the next one, f equals 3c minus 4, and I want to make c the subject. So this minus 4 over here is going to move to the other side. F plus 4 equals 3c. Just like solving an equation, I'd want to get rid of that 3 now, so I divide. That leaves me with c equals f plus 4 over 3. Remember, this is just like solving equations. But we don't know the numbers. So we can't add, subtract, multiply, or divide. Okay? So there's our formulas. Let's have a look at the next question. We're asked to find the gradient of the line from A to B. Okay? So here they haven't drawn the line for us, but it's a very simple matter to draw the line yourself. Okay? You would use a ruler. I don't have a ruler, but I'm going to do my best. Now I could take the entire triangle from A to B and work out the gradient that way, but instead I'm just going to take a small section because it clearly goes through a nice point in the middle here. I can see my rise is 2 units and my run is 4 units. If I'd have drawn my triangle bigger, I would have got 4 for the rise and 8 for the run. It would be the same answer. So the gradient is the rise over the run, which is 2 over 4, which is 0.5. Remember, don't just divide the big number by the small number. Now I want to write down the equation of this line. Now I can see that it goes through 0 on the y-axis. So c is 0. Y equals mx plus c is the gradient, is the equation of a line. M is the gradient. We worked out that that was 0.5. And c is the y-intercept, which is 0. We can see that from drawing our line across from A to B. So I could leave my answer like this, but it's also probably a good idea just to simplify it because we don't need that 0. Now we're asked to make A the subject of this formula. This one might come across a little bit scary looking because we've got a fraction, but we're going to treat that fraction like we treat fractions in equation solving. So I'll write it down. S equals A divided by 4 plus 8u. Now if that fraction is looking unpleasant, then our first job is to get rid of it. I'm going to times by 4 to get rid of the divide by 4. But I have to do that everywhere. I can't just do it to that fraction. It needs to go on to every term. There are 3 terms, so I have to do 3 times by 4s. S times by 4 is 4s. The divide by 4 and times by 4 have cancelled out, leaving just the a behind. And 8u times 4 is 32u. To make a the subject, I imagine that both of these are numbers, and I'm just trying to get a on its own. So I'm going to grab that 32u and move it to this side, where it's going to be a minus 32u. That's going to give me a equals the 4s minus 32u, and I'm finished. Let's have a look at the next one. Now once again, this one might look a little bit more complicated because it's got a squared in it. But actually it's not going to affect our work at all, because I'm interested in u, which means that I think of everything else. I think of d and t and k and t squared, all as just being numbers that I need to get out of the way. d equals ut plus kt squared. All of this thing over here, is just a number I don't know. And if I was solving an equation and there was a number over here, I'd want to move it out of the way. So d minus kt squared equals ut. I just take this number and I throw it to the other side, minus kt squared on the other side. Now this u over here, I don't want that. Oh, I do want that. I want to get rid of the t. This t over here is just a number. And just like all other numbers, if I divide by it over here, it'll go away. Of course, I have to do that on this side as well. And that's it. It's just the same as all the others, just with a slightly more complicated looking set of letters. But ultimately what we're doing is still collecting and dividing. Just to make my point very clearly here, let's pretend that d is a number. Let's pretend it's 5. Let's pretend that t is 2. So ut becomes 2u, if I'm pretending that t is 2. Let's pretend that kt squared is 3. Let's call it 3. So I've got d equals ut, 2u, plus some number, plus 3. Now we're looking at this equation and thinking this is very easy. I'd take this number and move it to the other side, and it would go over the equals and change its sign. Well, that's just what I did with kt squared. That's 5 minus 3 equals 2u. Now I'm going to be lazy, and I'm not going to work this out. Over here, it's not laziness. I can't work that out. But over here, I'm going to just be lazy and not bother. So I imagine what this would be. It would have to get divided by 2 for my final answer, just as I divided by t over here. So my final answer is a very lazy 5 minus 3 over 2. 5 minus 3 over 2. Over here we can't work it out because we don't actually know what numbers are being represented. And over here it's just laziness. But I'm doing exactly the same maths. This equation, this nice simple equation over here, has the same structure and is dealt with the same way as this very complicated looking formula over here. Okay? And that's the end of that part of the solutions.